This is a review of Learning Target 27, which is the exponents rules. You can see in front of you the slide that we started with. The first property was product of powers, which says when we multiply two exponents with the same base, we add their powers. For example, if I have a squared times a to the third, we would add the 2 and 3 together to get 5 for my power of a. The reason why this works is a squared is a times a cubed is a times a times a, and the way we would write that when we multiply them all together is a to the fifth, because I have 5 a's that I am multiplying. Another example, x to the fourth times x to the third equals x to the seventh, because we're adding 4 plus 3 to get the 7. In a few minutes, you're going to see this extends also to when we have a product of powers with several things multiplied. The next rule is the quotient of powers. In this case, we subtract the two powers when we are dividing an expression that has the same base. So if we go back to an example from before, a to the fourth divided by a to the third, this would be the same as having 4 a's multiplied together on the top, divided by 3 a's multiplied together on the bottom, and then we can reduce 3 of those 4 a's, leaving us with a to the first. Again, the shorthand way would be to subtract the 4 minus 3. Keep in mind, too, you want to keep things positive for your powers. So, for example, if I have x to the 10th divided by x to the 4th, in this case, we would take 10 minus 4 to get 6. Since the larger power of x is on top, we would just write x to the 6th, not in fraction form. If we have x to the 4th divided by x to the 10th, again, we want to keep our power positive. Larger power of x is on the bottom. 10 minus 4 is 6, but I can't leave the top blank. We need to remember there is actually a 1 in front of my exponent expression. The third property is power of a power, which says when we are taking something and raising it to a power, we actually go ahead and multiply the two powers. Example would be something to the effect of a to the third raised to the second. We multiply 3 times 2, we get 6. The reason it works is this is a cubed times a cubed. Again, 3 plus 3 also gives us a to the 6th. And if I go as far as to write it longhand, you can see that I have 6 a's multiplied together. Okay. Example of this would be x to the 4th squared. We would multiply the 4 times 2 to get x to the 8th. There are two properties that basically says we're taking a product or quotient and raising it to a power. And effectively what happens is it's like you're distributing the power. Something such as this. Okay. So for example, if we had 2x cubed raised to the third power, we would take the 2 and cube it, as well as the x cubed and cube it. We don't normally write that step out, but I want you to understand where the answer comes from. 2 cubed is 8. X cubed cubed is x to the 9th. Remember from the previous slide, we are multiplying powers. So if we take this a little bit further and say we have 3x to the 4th, y to the 7th, we square it. We're going to take the 3 and square it. We're going to take the x to the 4th and square it. We're going to take the y to the 7th and square it. Again, we don't normally write this step out, but I want you to understand where the answer comes from. The answer I would get is 9x to the 8th, y to the 14th. The last property that we have is power of a quotient, which says if we have a quotient, we're raising to a power. Again, it's kind of like we distribute that power. An example of this might be something like x to the 4th divided by y to the 3rd. Again, we're going to cube that. So effectively, it's like we take x to the 4th and cube it, and we take y to the 3rd and cube it, which gives me x to the 12th over y to the 9th. Again, this middle step here, you don't have to write out. I'm showing you where it comes from. Another example, 2x cubed divided by 3y to the 7th. We're going to raise that to the third power. So that's effectively like taking 2 cubing it, x cubed cubing it. So it's kind of like we're combining the two properties we just talked about. 3 cubed and y to the 7th in cubing it. Again, you don't have to write that step down. This gives you 8x to the 9th over 27y to the 21st. Couple of other examples. You might see something like this: 3a to the 4th, b to the 3rd, times 2a to the 6th, b to the 8th. You're going to multiply the numbers. 3 times 2 gives you 6. Add the powers because you're multiplying them. Make sure you're only adding the ones for a and the ones for b. A to the 4th, a to the 6th, 6 plus 4, 10. B to the 3rd, b to the 11th, 3 plus, or b to the 8th, 3 plus 8 gives us 11. 6a to the 10th, b to the 11th. Last example with division, 3x to the 3rd, y divided by 6, xy to the 4th. I can reduce the 3 over 6 to give me 1/2. You don't have to write the one on top, but you can. X, larger power is on top. 3 minus 1 is 2, so it's x squared. Larger power of 1 is on the bottom. 4 minus 1 is 3. And that concludes the review of Learning Target 27, which is the exponent rules. Thank you.